All right, if I can have your attention, please. Yesterday, we started discussing exponent rules. All right, that's your cue to stop talking. You need to have your notes out. You should already have your notes out.
Your notes that we took yesterday? Yeah, notes.
All right, so we talked about the product rule yesterday, and we even got into doing some examples.
No, we didn't finish 5 this.
Yes, we did.
No, we didn't.
Yes.
All right, I believe this one's the last one we did, correct?
Yes.
Okay. All right, the next one you need to do, remember, if there's coefficients in the front, you multiply those first, and then you add the exponents of like bases. Okay. All right, here's your next one. Write that problem down. Negative 5x to the 4th y times 3x to the 6th y to the 9th. All right, so write that one down. All right, so remember, the first thing you need to do is multiply the coefficients. Well, the coefficients are negative 5 and 3. So my question to you is, don't call out the answer because I'm going to call on someone random. What is negative 5 times 3? Daniel.
Negative 9. What?
Now make sure you didn't type in negative 3 times 3.
Negative 15.
Negative 15. So first you do negative 5 times negative 3, which is negative 15. Now you do the variables. And remember, how to know which variables to do first? Go in alphabetical order. Since x's comes before y, do your x's first. So my question, I accidentally already pointed to the person, but what would x be raised to the power of, Ethan?
4.
Well, I've got x to the 4th times x to the 6th.
Oh.
It would be x to the 10th. Good job. You add 4 plus 6.
Sorry.
Okay, so we get negative 15 times x to the 10th. Now do the y's. You have y times y to the 9th. This one's tricky. Caleb, what do you get when you multiply y times y to the 9th?
Oh, okay.
How did you get 10?
Because there's a y with a power of 9, and then there's a y, just one y right there.
Yeah, there's a 1 right there. Perfect.
I believe
That is 0, like right above the x.
Yeah, it's x to the 10th.
No, that's it.
Yeah, it's
All
not.
right, so our final answer is negative 15 times x to the 10th times y to the 10th. All right, what questions do you have for me on multiplying expressions with exponents? All right, Amber, once you get situated, whenever we get a moment, like a break, you'll need to get this problem from one of your classmates. All right, yes, sir.
Oh, so I have a question. So if it's a negative, like, see, we have that negative 5, it doesn't matter if we still go in alphabetical order, even if it's a negative?
A negative number has nothing to do with alphabetical order. The negative goes with the coefficient, it doesn't go with the variable.
The alphabet doesn't have negative. Yeah, it does. You go backwards, you get negative.
Oh.
True.
We have another example.
Yeah, negative 7.
Okay, number 7. 4x to the 5th times negative 2x squared y plus 5xy squared. Okay. 4 times x to the 5th times negative 2x times x squared times y plus 5 times x times y squared. Okay, see how there's 2 different things inside here? You've got to multiply the 4x to the 5th times the first one, and then you got to multiply it by the second one. You have to distribute. Just like before when we were distributing a number, we're distributing a whole monomial.
Oh, what?
A monomial. This term right here is a monomial because it has one term. this expression has two terms, so it's a binomial.
Sounds like I'm saying wrong.
Okay, so first I'm gonna multiply 4x to the 5th times negative 2x squared y. Then, and there's a plus sign there, so we hit plus. I'm gonna multiply 4x to the 5th times 5xy squared. Okay, and I'll give you a second to write that down, but I'm gonna show you a problem that's just like this, but that's a lot more simple.
That's a lot.
What we did previously, earlier in the year, we had like 4 times x plus y, and we had to distribute the 4 to the x and the 4 to the y, and so that would be 4x plus 4y. That's what we did previously, in a previous chapter. Okay, well, this is the same thing, just a little bit more complicated. Okay, so you're going to use the same rules we used before. So first thing is multiply the coefficients, 4 times negative 2. Well, 4 times negative 2 is negative 8. Then multiply the x's. X to the 5th times x squared would be x to the 7th. And there's no y's here, so I just leave it as y. So my first one comes out to be negative 8 times x to the 7th times y. Then copy your plus sign down. Now I multiply the 4 times the 5, and I get 20. And then I multiply the x's. This has a 1, so that would now be x to the 6th. And there's no y here, so my y stays as y squared. And there's your answer. And I cannot add these together because they're not like terms. In order to be like terms, they would have to have the same variables and the same exponents. So they would both have to be like x to the 7th times y. Or they would both have to be x to the 6th times y squared before I could add them together. But since they don't have like exponents, I can't multiply them together.
Now we got divide.
All right, now, before we move on, what questions do you have for me?
This is confusing.
This one here is a little bit more complicated. I got this problem from the Algebra 1 EOC. That's the end of course assessment that you'll have to take when you're done with Algebra 1. You will be taking pre-algebra this year, Algebra 1 year 1 next year, and Algebra 1 year 2 your 11th grade year. And at the end of 11th grade, you'll be taking the Algebra 1 EOC.
So we only got to take one EOC.
For math.
What about for like world history or?
I think you take a government one.
Yeah, you take government, they don't have one for history.
Okay, it says, in order to simplify, you must distribute. Since you are multiplying when you distribute, you must use the multiplication rule for exponents. Okay, write this problem down. You see where it says divide? I need you to write x to the 5th divided by x to the 3rd. Now, what does x to the 5th mean to do again?
X times x times x times x times x times x.
Like that?
Yeah.
And what's x, and that's divided by x to the 3rd? What's x to the 3rd?
X times x times x.
Times x.
Okay, like that right there.
On.
Alright, now, I have a question. If I take 2 and divide it by 2, what do I get?
1.
If I take 7 and divide it by 7, what do I get?
2.
100 divided by 100.
2.
A heart divided by a heart.
2.
Half of a heart.
A broken
Broken
heart.
heart.
What about x divided by x?
X.
Uno.
I said that.
Anything divided by itself is 1. So, right here, you see where it has x divided by x? That's 1, so they cancel out. X divided by x
That's gonna be 2.
is 1.
It's gonna be 5.
X divided by x is 1. What's 1 times 1 times 1? 1.
Two.
So, and pretty much all of this is 1, so that's 1 times x times x. So you can really forget about the 1. What's x times x?
2.
Hey,
Oh, 1.
What's x times x?
X. 1 over 2.
X to the power of 2. X squared.
So you're just subtracting.
Do you see a quicker way to get that other than that right
yeah,
there?
just take the 2 that
5
don't have
minus
anything
3.
under 'em.
Anytime you're dividing numbers that have the same base, all you have to do is subtract the exponents. So, turn it over to the back. You see where it says division rule? On the back. You're supposed to turn it on to the back.
Oh.
You see where it says division rule? It says, if the bases are the same, subtract the exponents. You need to fill in the word subtract. If the bases are the same, subtract the exponents. And then it says, notice I have a note over there for you. It says always do top exponent minus the bottom exponent. It's always the top one minus the bottom one. And then right there underneath the statement, not where it says example, underneath the statement, you need to write this rule. So underneath the division rule, you need to write this. X to the m power divided by x to the nth power and equals x to the m minus n. And then I have an actual example for you to write down beside that. The example we did, instead of going through all that work, if you have x to the 5th divided by x to the 3rd, that equals x to the 5 minus 3. Well, 5 minus 3 is 2, so it equals x squared. We have not made it to the examples yet. You just need to be writing down. Remember, I'll take questions in a moment. So we have not made it to the examples. Underneath the division rule, you need to write the actual division rule. X to the m divided by x to the n equals x to the m minus n. And then right beside that, have an example with actual numbers, like the one we worked together. X to the 5th divided by x to the 3rd equals x to the 5 minus 3, which is x squared. All right, let's do an example.
Wait, Miss Goodman.
Nickelodeon.
All right, number 1. Write number 1 down.
I can't see you there.
X squared y to the 6th divided by xy squared. X squared y to the 6th divided by xy squared. Okay? So to do this, here's what you need to do. First, look at the x's. Remember, this x has a 1 as an exponent. So you would do 2 minus 1. And then for your y's, you would do 6 minus 2. Now, I'm only showing this step right here so you can see where my numbers come from. And you'll see in just a moment, I won't even be doing this part because you can do the subtraction hopefully pretty easy in your head or in your calculator. All right, so x to the 2 minus 1. 2 minus 1 is 1, so it's x to the 1st power or just x. And 6 minus 2 is 4, so it's y to the 4th. So my answer is x times y to the 4th.
That's way easier than that.
Okay, let me show you another one. Write this one down for number 2. 6 times a to the 7th times b to the 3rd divided by 2 times a times b to the 2nd. First, you look at the coefficients. My coefficient on the top is 6, and this one's 2. All that means is 6 divided by 2, which is 3.
Darn.
Looks like a one.
Then, for your A's, you're going to do 7 minus 1, which is 6. So it'd be A to the 6. Then you're going to do your B's. 3 minus 2 is 1, so it'd be B to the first or just B.
Just
Just do.
So my final answer is 3 times A to the 6 times B. Alright, let me show you one more. Number 3. X to the 5th times x to the 8th divided by x to the 3rd. So write that problem down for number 3. Alright, so before I can divide these, I need to simplify the one on top. Okay, let's put our calculators down. Pay attention, please. Whenever you're multiplying, you add the exponents. So first you do 5 plus 8, which is 13. So I get x to the 13th power divided by x to the 3rd. Now I can divide, so I'm subtracting the exponent. So I do 13 minus 3, which is 10. So that's x to the 10th power. What questions do you have? Some of these are a lot of steps.
Or does it have words?
Parker?
so if you add a to the 7 plus b to the 3rd, wouldn't you just multiply 7 times 3?
They're not like terms, so you can't. You can only do it with whenever they have the base, the same base. So since that's an A and that's a B, you can't do it.
So about a to the 7 plus a. That'd be
That would be A to the 8. Oh, wait, you're saying can I do A to the, if it was A to the 7th plus A to the 1st? You can't add those. You can only add when it's like terms. So it has to be A to the 7th plus A to the 7th, which is 2A to the 7th. Daniel, is that one dead?
Yeah.
Put it on my desk. Yes, sir.
You want a worksheet?
I'm only asking questions about this. Okay, let's go on to another one. Special cases, 0 power. So you see where it says 0 power? Right there beside 0 power, you're going to write any base raised to a power of 0 equals 1. So write that down where it says 0 power. Write that statement down. Any base raised to a power of 0 equals 1. Then once you write that statement down, right underneath the statement, not in the examples, underneath the statement, you need to write x to the 0 power equals 1. And I will show you in just a moment why.
We need to write down the here's why.
I'm going to show you that in just a moment. Any base raised to a power of 0 equals 1. So if you have 10,000 to the power of 0, it equals 1. If you have 2x squared, the whole thing raised to the 0 power, it's going to equal 1. Alright, let me show you why. There's a couple different ways I can go about showing you why. Let's say you have x squared divided by x squared. Okay? Well, x squared means x times x. And this x squared means x times x.
So you write this down.
No, I'm just showing you why. X divided by x is 1, and x divided by x is 1. And 1 times 1 is 1. Okay? Now, previously, what's the rule to do whenever, let's put our calculators down, please. What's the rule that I use whenever you're dividing?
Subtraction.
You subtract them. So this would be x to the power of 2 minus 2. What's 2 minus 2?
1, 0,
0.
Oh.
And what does this equal?
1.
So x to the 0 power is 1. Okay? Another reason why, or another way I can show you. Two to the fourth, 2 to the third, 2 to the second, 2 to the first, 2 to the 0. And 2 to the fifth. Someone tell me, or everybody, don't just someone, everybody type in your calculator 2 to the 5th power and tell me what you get. And don't call out the answer, I'll call on someone to give it to me. Michelle, what'd you get? 32? Okay. Now everyone type in your calculator 2 to the 4th power. Gavin, what'd you get? 16?
Yep.
Now type in 2 to the 3rd power. Ethan, what'd you get?
8.
Now type in 2 to the 2nd power. Alex, what'd you get?
4.
Does anyone see a pattern here?
You divide it by the one half of itself every time.
So what are we dividing it by?
2.
You're dividing it by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. If I kept this same pattern and divided by 2, what's 4 divided by 2?
2.
So 2 to the 1st power is 2. Now to keep going, divide 2 by 2, what do you get?
1.
So 2 to the 0 power is 1. Ooh, but let us keep going. What's the next number underneath 0?
Negative 1.
What can I do to get 2 to the negative 1?
Put in negative 1.
Times it by negative 2.
Not, all I'm doing here, I'm dividing by 2. So every time my exponent decreases by 1, I divide by 2. So do 1 divided by 2. What do you get? 0.5, which is the same thing as 1/2. Now we're going to do 2 to the negative 2. So take 1/2 and divide it by 2. What do you get?
25.
25.
0.25, which is 1/4. Now we just got into negative exponents.
Great, we got the fractions.
Perfect.
Exactly.
Trade it out for another one and put that one on my desk.
Oh, it's just like this little fraction.
Alright, so that's how come 2 to the 0 power is always 1.
Instead of using fractions, using decimals.
You're going to want to get used to using fractions because once you get in higher level classes, they're going to want your answers to be fractions. We hardly use decimals after we pretty much figure out how to do fractions. Like all of my math professors in college, like they would not accept a decimal as an answer. Like you had to write your answer as a fraction. Math people don't like decimals.
Why? It's part of your math.
It's because it's easier for it.
All right.
Than that.
Let's do these examples together. Number 1, a to the 3rd, b to the 4th, divided by a to the 3rd, b.
Not whenever you're reading a tape measure, it's 0.25 means quarter of an inch.
A tape measure is in fractions.
Yeah.
So you gotta know
It's
that.
a little bitty thing.
That they're in
It's
fractions.
16.
So again, they want it in fractions. Okay. What do you notice about the A's?
They're the exact same. They're equal.
They're equal. So if I were to do 3 minus 3, what do I get? 0. So you get a to the 0. And then what about the b? What's it going to come out to be? 3. So I have a to the 0 times b to the third. What's a to the 0 power?
One, or
It's just 1.
But-
So that would be 1 times b to the third. Do we ever see a coefficient of 1? No, it's never there. So we just leave it as b to the third. So our final answer would be just b to the third.
So does
I
that mean-
hate this.
So does that mean that there's a zero? But if there's an A, you said it'd always be one. But the exponent would cancel out the A. Will it be a one?
Anything to the 0 power is 1.
Boys,
A is raised to the 0 power, so it
I
equals
swear, I
1.
think I just saw.
So it would just be A one.
No, it's not a to the first power. It's a to the 0 power. A to the 0 power is 1, not a to the 1, just 1. Alright, number 2. Let's write this one down. 10x to the 4th, y to the 3rd, divided by 5x to the 4th, y squared.
They have 4s.
Alright, so first, do 10 divided by 5. Caleb, what's 10 divided by 5?
2.
Okay. Now, what's going to happen when I do 4 minus 4?
You're gonna get 0.
You're going to get x to the 0. And also, what happens when you do x to the 4th divided by x to the 4th? What does it do to itself?
Cancel out.
It cancels it out. So you can pretty much just forget about it. And then, what about the y? 3 minus 2.
Just be y.
It would just be y. Y to the first.
It
or
wouldn't
just
be y1
No, because you don't write a 1.
since when?
apparently since ever.
Yeah, we just wrote the 1 so we'll know that's how many exponents it had.
But what if I want the 1?
Singular.
I'm losing brain cells listening.
I want one now.
Alright, right here. M to the 10th times n to the 5th divided by m to the 10th. Ethan, you doing okay? You got this one written down? M to the 10th, n to the 5th.
Yeah, this is like right?
It's the same. It's cancels out the numbers.
So it's
So
M.
equals 0.
So it's M.
No, it cancels it out.
Just cancel it out.
Okay.
Cancel it
Well, let's do it this way. Let's do 10 minus 10. What's 10 minus 10?
0.
It's just M.
What's 5 minus 5?
0.
Now, what's m to the 0 power?
0.
No.
1.
M.
1.
So it'd be 11.
What's n to the 0 power?
1.
So you got 1 times 1,
Which is 1.
which is 1.
11. No.
Oh, it's one.
You don't add the
One.
other.
No. Put 1 plus 1.
It's
But
1
you're
times
timing.
1. It's 1.
Then.
Also, what do you notice about the top and the bottom?
They're the same.
And what's anything divided by itself?
1.
1.
Uno. Dos,
One.
dos, yes.
Probably the easiest problem, but probably the most missed.
No.
Alright, before we do another example, what questions do you have for me?
Why do you have to make me lose so many brain cells doing these things?
You have brain cells?
Not at the current moment.
And this is the kind of math I like doing.
Well,
it's
same
horrible.
here. I was doing this after.
Alright,
Don't
write this statement down. Write this statement
Do you
down
like doing
for the
this?
next example. The product of 3 to the 5th power and 3 cubed. So write this
On number
statement
4,
down.
you want me to write that?
This is example number 4. Write this statement down.
I write it
Or number 4.
I mean, I'll follow with it.
The product of 3 to the 5th power and 3 cubed. So the first thing we're going to do is rewrite this as an algebraic expression or a mathematical expression. Then we're going to evaluate. So what does product mean to do?
Multiply.
Product means to multiply.
What is wrong with your
And it tells us to multiply 3 to the 5th. How do I write 3 to the 5th power?
3 over 5.
3
3 over 5?
to the 5th.
3 to the 5th power. And then product means to multiply. So 3 to the 5th times, what's 3 cubed look like?
power.
3. A cube is 3.
Yes, let's.
Square
Cube
is
is 3.
Square is 2, cube is 3.
Yes, let's. She say 3 over 3.
Now,
Cube and square, the same thing.
how would I solve this? What would I do? Say it. I heard someone say it.
You multiply.
You add them. What's 5 plus 3?
8.
So this would be 3 to the 8th power. You should be writing this down.
Whew.
Now, to actually solve it, you just gotta type in your calculator 3 to the 8th power. And Chase, what did you get?
A big number.
I'm sorry, say it a little bit louder. This air conditioner's loud. 6,561. Do y'all agree with that?
Yes.
Oh, may I have your attention, please?
Yes.
Just a reminder that seniors need to go to the auditorium during lunch feed. Take out their
Jason, why did you get so nervous?
Thank you.
You see that, dude? Jason jumped out his seat just about to
Okay, let's do this one.
He said, oh no.
He thought he was going to
This is number 5. Write this statement down. The quotient of 3 to the 5th power and 3 cubes. The quotient of 3 to the 5th power and 3 cubes.
And I need to work.
Alright, what does quotient tell me to do?
Divide.
Divide.
Girl, can I have your brain?
I don't know.
So-
A little bit chunk of it.
So we're going to divide. What am I going to divide?
We're going to divide 3 to the 5th power by 3 cubes.
I don't want that.
Yeah, so that means 3 to the 5th divided by 3 to the 3rd. Alright, Daniel, what do I do with my exponents?
Put them someplace.
No, my exit. You're going to subtract. Alex, what's 5 minus 3? 2. So you're going to do 3 squared. Gavin, what's 3 squared?
9.
And there you go.
Y'all was really like trying to call him out.
Let's go.
What questions do you have for me on dividing?
I think we need to work on this a little longer.
I think that's why I should
Alright,
Looking at it online.
these notes need to be the last page of your folder.
They need to be put in a hole.
You need to put them in the prongs in your folder.
I wonder what would happen if this man like went out of business, you know?
Put your notes as the last page of your notes in the folder, in the prongs.
Not Thursday.
Ow.
No.
Oh.
Yeah, my daughter's taking my dad's credit card to sign them.
Alright, once you get your notes in your folder, go ahead and pass your folder to the front.
There you go.
Who? What's the difference?
Second row, you can go ahead and turn in your calculators and get your phones.
No, do not take your time.
I haven't had it online.
Shut up. Not in this
I had it
conversation.
online teacher during the summer.
So that's where I had trouble.
The password.
And I realized I got caught up in the
I haven't told your, Ashton,
Oh,
have a seat. I haven't told your group to get up
oh,
yet.
my bad.
Oh, you did? I thought you said fourth row. Okay. Can I tell you the way then?
In a moment.
There's only 2 things I got this second note. I got some.
Row 3, you can put up your calculators and your phones.
You have a calculator back there that has a little hole like that.
Yeah, it's from someone that sits over here.
Amber.
Their pencil, not their eraser.
Hey, just give me a stick.
No, I didn't know who it was.
Yeah.
They said over here.
Give the whole world ASD.
What?
Lastro, you can put up your calculators against your phone.
Hey, you better not do that, cause I ain't even right.
Stuff away while you're up.
It's from different class.
Yeah, chill out.
Hey, Ashley, your bottle came's right there.
Hey, so I'm about
I'm
two on
old.
that.
You don't have to old one like that? They said my kids have.
Funnier when you do it.
No, you're I didn't show you.
He trying to knock down an old woman. You see that? Man, she-
I got you.
I am. I feel like one. My body hurts. My
Nah,
legs.
you just
My
Okay,
knees
guys, have a
cracking.
seat. The longer you
Yeah,
take,
sit
the
down.
longer
My
you
knees
stay after
crack.
the
Back your
First
able
is
to
fine.
the cracking is in my knees.
First row, you put up your calculators and get your phones.
First is a sign you're doing a lot of exercise.
No, it's not.
I ain't got the water bottle here.
That's something I'm out of shape.
You're out of shape, huh?
I'm sick of you, child.
He's not a child. He is.
Yeah, you don't care. I'll show you. You'll definitely.
He is a. You know, like 2017 or some kind. You gotta roll your R's. Oh,
Yeah, let me get your.
Bro, if you listen to Cardi B, you're weird.